Hey everyone, let's make de novo synthesis of purine and pyrimidines easy. De novo means starting from scratch. Not all purines and pyrimidines are made from scratch. Many of them are actually recycled, which is a different pathway. But we're more worried about the de novo today. Let's get started. First, you should know the purines. This includes adenine and guanine. You can remember this with the mnemonic pure as gold. Pure for purines, and A and G stand for the first letter of the base pair. Next, the pyrimidines. This includes cytosine, uracil, and thymine. You can remember this using the mnemonic cut the pie. Each letter in cut stands for the three base pairs. Now that we know the base pairs, let's talk about the synthesis. Both purines and pyrimidines can be made from a substance called PRPP, which stands for phosphoribosal pyrophosphate. If we are making purines, we are going to start by making IMP from that PRPP, which can then create GMP and AMP. If we are making pyrimidines, we start with UMP, which can then make UDP and split to form two substances, DUDP and CTP. DUDP is further broken down into DUMP and DTMP. That is our pyrimidine synthesis. But this is just a quick summary of how they can come together to form PRPP. Let's get a little bit more detailed into this. First, we're going to talk about just purines in more detail, basically zooming in on that condensed diagram I drew. This is more so the chemical logic that Dr. Pirich talked about, but I highly suggest going back and reviewing his slides. We start with the PRPP, which actually first originates from ribose 5-phosphate, which makes PRPP using an enzyme called PRPP synthetase. From PRPP, we make a substance called 5-phosphoribosylamine. We make 5-phosphoribosylamine through an enzyme called PRPP aminotransferase. This is where IMP is created. But it is important to know that in this step, we use the GAG amino acids, glycine, aspartate, and glutamine. We also use thymine, the base pair, as a carbon donor to create that IMP in the first place. From IMP, we can get GMP and AMP. We actually use amino acids again to create this. Interesting, the G in glutamine tends to match with the G in GMP, likewise with the A in aspartate and AMP, if it helps you remember. Now, let's talk about pyrimidine synthesis in more detail. Remember, PRPP originates from that ribose 5-phosphate. This PRPP is basically making our UMP, but this PRPP uses CO2 and orotic acid to make the UMPP. But where does the orotic acid even come from? This comes from carbamoyl phosphate, which originates from the urea cycle. If you didn't watch our last video about the urea cycle, I'd consider going to watch it now. It uses these things plus aspartate to create that carbamoyl phosphate. This reaction here is stimulated by an enzyme called CPS2, or carbamoyl phosphate synthetase 2, which is our regulatory step in this process. If you're wondering what CPS1 is, it's the enzyme that we use to make carbamoyl phosphate in the urea cycle. So now, our carbamoyl phosphate gives rise to our orotic acid, but the step also needs an amino acid, namely aspartate. Remember, the purine synthesis also needed aspartate as a reminder. Now, we're back to the beginning. We have that orotic acid that uses the PRPP and CO2 to make UMP. Now, that UMP is going to make UDP, which can then be split to form DUDP and CTP. This step is stimulated by an enzyme called ribonucleotide reductase. It is inhibited by a cancer drug, hydroxyurea, which is clinically significant. Let's continue from our DUDP. It forms DUMP, which can then get DTMP. This step needs folate. How exactly do we use folate here? We have something called N5-N10 methylene tetrahydrofolate. We use this in this step with the DUMP, which is then converted into dihydrofolate. DHF is then used to be converted into tetrahydrofolate, which is then converted again into N5-N10 methylene tetrahydrofolate. The step from DHF to THF, we use the enzyme dihydrofolate reductase. This step is inhibited by a bunch of drugs, like methotrexate, which is an anti-cancer drug Dr. Pirich mentions in his lectures. From DUMP to DTMP, we use the enzyme thymidylate synthase. What's interesting is if there is a fold in this pathway and UMP cannot be created, uridine can jump into fill-in and then synthesize into UDP. But that's all I've got for you. If you have any questions, refer to CampusWire or your SI leader. Have a great week. We'll see you next Friday.